Hello, good morning guys. Alright, my previous video I tested the SSF 1006 fats, right? SSF 1006 fats for run 7 kilowatt inverter with parallel technique 4 kilowatt transformer, but it's not efficient. So I decide build one big giant transformer. Now he's here, has arrived. So big and heavy, but the little problem I got, the manufacturer sent to me 225 volt transformer. It's a little bit disappointed, but I ordered 230 volt spec transformer, but I got 225, but it's still acceptable, 225 volt, because our country is a Commonwealth, 230 to 245 volt. So 225 still can use. Okay, see, the previous I tried to run 7 kilowatt with parallel 4 kilowatt transformer like this. So the parallel technique is not efficient in terms on cost because it's high and transformer is very heavy. So you see that the different look small and this 7 kilowatt look giant, and the cable also big. The primary cable also big, AWG10. Okay, so the main board I already installed a high performance Mosfet IRFB4110 PBF. It's 24 pieces, what the grow watt 6 kilowatt use. Okay, so the fans I installed the two front and rear. The filter caps is 10 microfarad. So I hope with this my new transformer can go 7 kilowatt at 225 volt, because this transformer is 225 volts. So we try to the best today. Okay, firstly I want to show you the efficiency, what the best efficiency this transformer can give me. So I run to 1 kilowatt only load, 1 kilowatt, and then we measure the efficiency, how many efficiency the best transformer can give me. Alright, let's go. Alright guys, so the main board already connect to the transformer, and now I try run only 1 kilowatt, so see how the efficiency transformer can the best give to me. Okay, so the use normal formula, P out P in times 100. So I got efficiency. So P out, I'm just use the kWh meter, and the P in I measure manually, use flux tong meter and multimeter. So now the standby only 0.7 amps. 0.7 amp is a good news for 7 kilowatt low frequency inverter. 0.7, very efficient, more efficient than the high frequency inverter in term on standby mode, you know. 7 kilowatt, 0.7 standby. Okay, so starting the load now. 1006 22 amps at 50.6, 22 amp 15.6. Alright, so this is for 1 kilowatt, just use filament bulb. let's do the calculation now. So P out I got the 1006. So find the P in. 15.6 times 22. 1113. So I got the 1113. So 1006 11113 times 1100. So I got a 19.3% efficiency. Good news for me and good news for everyone. So 90% efficiency is a very good for low frequency toroidal transformer. I can say it's a par for compared to high frequency inverter. 19% efficiency. Good job. Okay, let's do the full power 7 kilowatts. What happened? Full power 7 kilowatt. I need to 400 Ah 51.2 volt battery pack outside. So I will bring out this module to the test 7 kilowatt flat. I promise it can go 7 kilowatt. Let's go.
1 hour later.
Alright guys, now we are in the test labs or test field. My new 7 kilowatt giant toroidal. Look, it can swallow my hand. Alright, and the Mosfets already assembled, the IRFB4110, and then I put the two fan here, front and rear. The rear is a low mode running, and this is for thermal sensor fans. The grid is the standby consumption only 0.7 amps. 0.7 amp for 7 kilowatt low frequency. This is a very great. 0.6 amps, 7 kilowatt. You never got the inverter efficient like this for standby mode. Okay, now the idle voltage is 227 approx. So my battery banks already fully charged here. And the test load, I use a 2 kilowatts kettle, 2 unit iron, and the 2 unit heater, and the thermopod, another one, the filament bulb, 600 watts. So the total load is about 7 kilowatt. And this is my kilowatt hour meter or kWh, watt meter, which shows how many watt you drains. And let's start. Okay, don't waste time, let's start and let's blow the fats. Okay, 7 kilowatt, go. 2 kilowatt, 3 kilowatt, 6 kilowatt, 7 kilowatt. It's a bingo, 7 kilowatts. The voltage is not 6, maintain 224. The current is 150 amps. And then take the temperature pads. It's normal, not heat anymore. The fan running full speed. 40 Celsius, it's normal. This is a grid pads, 43, fan with full run. Okay. Okay, let's see the water start to boil. You see, water's boil, and the temperature transformers is 42. It's a normal look like fan running high speed, the inductor is 43, normal, pads 35. I need to stop now. So I declare this project is successful, runs 7 kilowatts without issue. So the IRFB4110 pads, a good choice with a high power inverter. Good. Alright guys, let's study the block circuit diagram. Okay, this is the main brain. The main brain, the inverter system is GSZ02 SPWM, easy to get to online store. Okay, my design inverter is different. What the difference is, for the overload protection, I'm not use resistive sensor. Resistive sensor is not accurate if sensor getting heat. If sensor getting heat, the value will trip, maybe high ohm or low ohm. So I decide use to more precise CT sensor. The code name is ZMCT103C. This is more precise. So you only need live or neutral cable through it, like this, in and out. So this CT sensor will read the voltage and send to the EGS. So you need to calibrate the port here, 1K resistor. The port you need calibrate what maximum watts you need to cut. Okay, and then the pin is normal. You follow to the diagram. Follow to the diagram, and then it is a normal NTC 10K thermal resistor. Must to fit to heatsink. And this is for turn on the cooling fan. So I'm use 24 volt fans. Why I'm use 24 volt? Because 24 volt is low power consumption. So if I'm use the 12 volt fan, 12 volt fan is higher current consumption. So I decide use 24 volt. And then this for voltage feedback. This is live and neutral, need feed to output transformer for voltage feedback regulation. And this is a AC voltage adjustable. This port 10K, you need adjust what voltage you need, 220 or 230. Okay, this chip EGS only maximum drive 3 FET per channel. So if you want build a big inverter, let's say 6 kilowatt above, at least you need a 6 FET per channel. So the chip unable to drive 6 FET. So you need build the totem pole circuit diagram. Let's see. The circuit diagram is P NPN and PNP channel, gain to 3 amps. So high output must feed in and high output out. VSS in and VSS out. Ground and low output out. So you need the X transistor for boost the output EGS SPWM signal. It's so easy, just follow this diagram. So the blocking diode is very important. Blocking diode supply for totem pole is a fast recovery 107. This is very important for prevent reverse voltage to main voltage. So you need a blocking diode. And then the next section, the MOSFET array or MOSFET board, MOSFET. For the MOSFET, you can choose the 4 type powerful MOSFET here. The first is IRFB4110 or SSF 1006 or HY4008P or Farnell FDP032 and 08. Up to you what MOSFET you want use. All MOSFET capable drive to over 6 kilowatt or 7. And then this is DC rail 48 volt and negative rail 48. So the FETs wiring need big the big copper wire or big cable need to drive the high ampere here. And then the signal FETs is here, high output VSS, low output, high output VSS, low output. Need connect from the totem pole circuit diagram. Okay, so it's easy. So the transformer ratio for these projects has two types. Okay, so you need the 4-turn ferrite choke. This choke just for the transformer ratio. The transformer ratio has two types. So if you use the VRLA or lead acid batteries, the voltage range is 42 to 54 volt. So the primary is 28 volt and the secondary is 220 volt. If you use the live PO4 battery 16S 15 volt to 15.8.5 volt, this battery is higher voltage than the VRLA. So the transformer ratio is much higher than 28. So the 32 volt primary and the secondary is 224 volt. Why 32 volt? Because the voltage is high for the live PO4. If you use the ratio lead acid for live PO4, you will get low efficiency your inverter, and the transformer will getting hot because the voltage is high. So your efficiency will drop to 85 or 82%. So if you use the primary 32 volt, your efficiency will rise to good 88 to 19%. 32 volt primary and secondary is 220 volt. So before design, you need see your battery type first and design your transformer. Alright. And lastly is the auxiliary power supply for the entire circuit. The auxiliary power supply, I'm only use the fixed regulator TLC 783C. This regulator is very expensive because capable drive 124 volt to lower 1.2 volt. Very amazing, right? Very amazing. But the current output only 0.7 amp. So the 0.7 amp not enough run the FETs. So you need put the current booster transistor here, tip 42C and tip 41C. This transistor rating is 100 volt, so more than enough drive to 48 or 16 volt. Okay, you connect like this, and then for 24 volt for auxiliary fan power supply, 12 volt for EGS 02 and totem pole, and 5 volt for EGS CPU. This is just use simple regulator LM7812 or 7805, 1 amp each. Okay, this is the complete circuit I showed to you. I hope my presentation is clear. So if you willing to build this circuit, just redraw back from your what CAD you use, Eagle, Proteus or whatsoever. I not provide any PDF document for circuit diagram. I'm so sorry. I I want you do your effort, redraw back, and build. It's not hard if you got good skill electronics. Alright. Thank you. Bye bye.